but it should. Now, factoring, finding factors. I'm going to show you the tree method. Now, on a test, this is the method you should use. But the book explains it like 0. So I'm going to do about 3 of them to see what's like. I get an amen from guys that you understand it. So in factoring, let's say I want to factor 48. So before you can factor, you got to know what the prime numbers are. 1 is a prime number, we won't count that. We'll put in 2, 3, 5, 7. What comes after 7 is a prime number? Anybody?
$11.
Exactly. 13, 17, and so on. Now, in order to use the tree method for prime factorization, you use the lowest number prime factor that's there, and of course, if you divide 2 into 48, you get 24. Now, you have to use the lowest one again until it runs out. The next one is 2 again, that gives you 12. Use 2 again, that gives you 6. Use 2 again, and you get 3. And the next one is 3. So that means prime factorized 48 equals 2 to the 4th power times 3 to the 1st power. 2 to the 4th power is 2 times 2 is 4, times 2 is 8 times 16. 16 times 3, 48. Is there any question about that one? I'm on to the next one. I'm going to do 50. So we're going to start with 50. We all know the first prime number is either going to be 2, which is going to give us 25. The next prime number that goes into 25 is not 2, it's not 3, it's 5. And then you use 5 again, and it comes out to 1. So 50 is equal to 2 times 5 squared. 5 squared is 25 times 2 is 50. You guys get the idea?
Yes.
Yes.
So this is called the prime factorization method using the tree. I'll do one more. 27. First one I use is 3. With 3 again. And with 3 one more time. So 27 is equal to 3 cubed. That means 3 times 3 times 3 is 27. It does. So I just wanted you to see that. Some of them look a little more complicated than others, but they're not. And so it's easy. But it's easy for me, and it should be easy for you. You just have to practice. Excuse me. I need a little lunch here. Let's get at it. All right. Let's go to the next one. Prime numbers. Well, you guys know what we've talked about. Prime numbers are numbers that if there's a natural number greater than 1 is called a composite if it isn't prime. Well, a composite would mean like we factored it. Can't factor it, it's prime. So we can't factor 17. We couldn't factor 2. We couldn't factor 3. And we can't factor 31. Those are prime numbers. You can always Google them if you don't know them. So we could do a quick test here. Is 34 prime or composite? Well, you can say it's composite. 29 is prime. 27, we know it's a composite. We just did that one. And 10 is divisible by 2, so it's obviously composite. Now, this is the numbers that are prime less than 50. And you can see what they are. 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 47. You guys get the idea. Now, they ask us to use the tree method to find the prime of 100. They kind of use a funny tree method, but it's 2 times 2 times 5, or 2 squared times 5 squared. And let me just show you this one, just to keep tuned, so you can feel good about. So we're looking at the prime of 100 factorization. We're going to start with 100. We know we're going to use 2 first. That's going to give us 50. We're going to use 2 again. It's going to give us 25. We know a 25 prime number is going to be 5. And then we use 5 again. And always have to end up with 1. So it's 100 is equal to 2 squared times 5 squared. 2 squared is 4. 4 times 5 squared is 4 times 25 is 100. Now, if any time you guys feel I'm going too fast, anybody, you know I love to explain it. Just say, hey, but I always get these little notes, Dr. Wickman, can you go a little faster? Don't tell us your personal stories. I got personal, so I'll try not to do that. But anyway, and now they're doing it the right way. Look at it. They're using 140, they go 2 to 7, there it is. And to go past that, 7 is 1 time. They don't quite finish it out, because 7 is a prime number, and anyway. 140 is equal to 2 squared times 5 times 7. The greatest common factor. Well, let's look at the first problem. Between 72 and 180. The greatest common factor is that number which can go into 72 or 180 evenly. And therefore, it can never be greater than 72 for the greatest common factor. Well, 36 goes into both of them, and that's what it is. Now, what I always try to do is try 72 first, then I use half of it, and then I go half again. And that's the best way to kind of, the shortcut way to do it. But again, what you need to know is the greatest common factor of 2 numbers can never be greater than the smaller number. So if I say, okay, I'll give you an easy one. If I say, what is the greatest common factor between 4 and 8, the GCF? Well, it can never be greater than the 4, and so in fact it is 4. So that should be okay. Very set. Back to our regular program. Greatest common factor, 3 numbers. Again, it can't be anything greater than the 40, but 40 won't work. You might try 20, which is half, and of course it is. That's the quick and easy way to do it. Always take the smallest number, see if it works, and then take half of that, and let's keep picking factors. Now, the least common multiple, whole different thing. Well, it says for 18 and 24, the least common multiple. That's the number that can go into both of them equally. So for 18, 36 less than 2, The first number that on both lists is 72. Again, what you're looking for is a number that both 18 and 24 can go into evenly. So in this particular case, it cannot be less than 24. 18 won't go into 24. So take the next multiple of 24, which is 48. And you look, 48's not in those. That won't work. The next one, after 48, another multiple. 3 times that would be 72. And 72 works because 18 goes into 72 and 24 goes into 72. So this is kind of the opposite. It cannot be anything less than the 24. And that's the least common multiple. Multiples are different than factors. Least common multiple, 24, 30, and 42 can't be anything less than 42. That doesn't work. So we're going to go to 84. That won't work. They just keep going of multiples of 42 until they find out that it is 840. It's a long number. But you'll find if you take 840 and divide it by 42, it goes in what, 20 times? And you know it has to end in a 0. You know the first two numbers have to be divided by 3 because this is a 30, and 2, 4 adds up to a 6, and that's divisible by 3. So, I mean, there's some tricks to it. But the best thing with your calculator is to take the large number, 42. If they won't go into it, then you take the next one, 84, keep going until you get the number that all three would like. Let's see. I mean, this is like the easiest problem. And by the way, it's on the test. I just can't believe it. And I don't know how anybody got this wrong in my last class, but one person did. And they did not attend the review. They did attend the class, but they missed the review. So, look. If hot dogs come in packages of 10, but buns come in packages of 8, how many packages of buns are going to have in order to get, solve all these, get enough of these hot dogs in buns? Well, if you get a package of 10 hot dogs, 8 buns not going to work, you're going to have to buy 2. That's all there is to it. 2 packages of buns. So if you want it to come out even, you'd take multiples of 10, which would be 80, and finally 8 would work because you could get 8 packages of hot dogs for 80 and 10 packages of buns, which would be 80, and so you could make that come out like that. Yeah, they also said 40, that works too. I like to sell more hot dogs. All right.